Good day, viewers. You are welcome to Soluble Tutors. Latitude and longitude are very important topic which you must understand. Okay, WAEC, NECO, JAMB, and other examination body are trying to set more questions from latitude and longitude now. So let's get into the class, and I will show you everything you need to know as regards the topic. Thank you for viewing.
Now, before we can understand this, the number one thing you have to bear in mind is to understand the four cardinal points first. Okay, where we have the north, okay, the what? The north, the east here, the west, and the south. So here we have the news. Are you getting it now? That's the common method to know. News, okay, northeast, west, and what? South. Now, to translate this one into latitude and longitude now, okay, latitude and longitude is talking about this cardinal point in the application to the health. Okay, now we use something like this to represent that, and we have the cardinal point there, which is the what? This. So we have the north, the south, which are the two important cardinal points. So we have the what? East and the what? West. And the west. Okay, and there are two circles in terms of latitude and longitude. We have the great circle and we have the small circle. But before that, let's talk about the latitude. Okay, latitude means when you cut the circle in an horizontal way, it's called the latitude. It's called the what? The latitude. When you cut it, it's like an orange. When you cut it in an horizontal way, it's the latitude. When you cut it in a vertical way, it's the longitude. Okay, and this is how we always make it. Whenever the latitude is moving, if it's moving towards the north, it will be becoming a small circle. Let's say, for example, you do this, okay, you do this, you can see that the latitude is cutting, okay, you see it's becoming smaller, okay, so this is called the what? The latitude, okay. For the longitude, we always start from the north and end in the south, just like this. That's the longitude. Another one like this, that's the what? Longitude. So we have it this way, we call it longitude. All right. Okay, now in terms of this latitude and longitude, we can be taking the distance from the equator. This center is the equator. Okay, so anything that forms in this center is also called the equator. Let's say, for example, this is 30 degrees. We call it north because it's going towards the north. Okay, this one will be like 50 degrees. Okay, as it increases, it's going farther away from the what? From the equator. So another one coming down like this. Let's say we have two circles for example. This is 30 degree, for example, south. It's going towards the south. This will be like 50 degree what? South. It's also going towards the south and going further from the what? From the equator. But talking about the longitude now, if it is the longitude, you can see that this one is detaching from the equator, is becoming smaller. But that of the longitude will never change size. It will only swing. It will only what? Swing. You can see this one swing towards the west. If another one swing towards the west again, the one that swing further will have greater value. Let's say, for example, if this line now is 30 degrees west, okay, 30 degree what? West. The one that goes further will now be something like maybe 50 or 60 degrees what? West. The higher the value, the more further it leaves the equator. The same thing applies to here. When it swings towards the east, and it swings again, it increases just like that. Okay, let's say, for example, this one is 30 degree what? East. Okay, so another one swings again, it gives us what? Another big figure that is going. Okay, that's how the degree is. So let's solve this question in terms of latitude and longitude. When you see this, find the angular distance between, you can see A, we have 40 degree north to 65 degree east, and for B, we have 35 degrees south to what? 65 degrees east. What do we do first? Now, this is the equator. Normally, the equator will have this curve. Okay. Now, it says 40 degree north. It means it's going towards the north. So you have to draw it this way. 40 degree what? North. You now label it as 40 degree north. Now, against 65 degree east. This is a swing, as I told you. The longitude will now what? Swing 65 towards east. Are you getting it now? 65 towards what? East. Look at it now. It swings towards east. So this line is representing 65 degree what? East. Do you get that? Now, that's our A. It means we are the joint. which good for this and this, is our what? Is our A. That's where they joined. Okay. Now this B, we have it 35 degrees south and 65 degrees east. Is sharing the same thing with this. But 35 degrees south, it goes towards the south. It's still a small circle. It's still a what? That's the latitude there. Okay. So I will label this one what? 35 degree what? South. Do you get that? Where they met, we call it B. We call it what? B. Mind you, my people. Now, the distance is between this A and B now. So what do? It will be related to the equator. To the what? Why are we relating it to the equator? Where what joined them started from is from north and south. Are you getting me now? So we can relate it to the what? To the equator. Now, we are asked to find the angular distance. The angular distance will be the distance between here to this place. Okay? Between A and what? And B. If we have to draw this, so it is like this. This is our A and this is our what? This is our B. The center here is here. Okay? Now, from this place to this place is the 40 because it's going up. So that's what? 40 degrees. Are you getting it now? From this place down is the what? 35. Don't forget. So that's our what? 35 degrees. So add me both together now because we want to know the distance to this distance. So our theta naturally will now be the addition of what? 40 and what? And 35. Okay. When you add both together, what do you now have? 40 plus 35 is what? Is what? 75. So we have 75 degrees. Okay. This is our angular distance that they want us to calculate. So this is another question, but it's not the same with the one we just solved. Now, find the angular distance between, just the same way, but it's not the same. 60 degree north will go a bit further. Okay? 60 degree north. So this is our what? 60 degree north. Okay? 20 degree west swings towards the west like this. So this line is our 20 degrees what? 20 degrees west. Okay? Where they met is our x as usual. Are you getting that, please? Now, as we go on, we are going to this y now. So 40 degree north is still north, but 40 degree is not as big as 60. So we're having it somewhere here. Okay, 40 degree what? 40 degree what? North. You will see that it's beneath 60 degree. That is very close to the equator, and 60 degree will be further from the what? Equator. 40 degree north and 20 degree what? West. Still the same 20 degrees. So it means here will be our what? Our y. Are you getting it, please? Now, to make this, now we have to start from the equator also, because anything on the longitude, anything on the what? Longitude. We make a great circle. Am I talking, please? So it will be like this. So you come down, and this one also comes like this. And we have to find this distance, angular distance. So let's sketch it out. If we have to sketch it out here, so it will be like this. So this line stands for this line, okay? So it goes like this and like this. Do you see that? So this y is here and this x is here, okay? So we have to find from here to here. How can we do that? Very simple. Note that 60 degrees is from this place to this place is what? 60 what? Degrees, okay? And our 40 degree is just from here to here. That's our 40 what? 40 degrees. To now get from here to here, for sure, we have to take this 60 and deduct 40 from it. Are you getting it now? Because this place is now the difference between the two now. So it means to get our angular what? Distance in this type of scenario now, we have to say 60 degrees minus what? 40 degrees. And that gives us what? 20 degrees. Mind you, this is just to calculate the angular distance. If you want to calculate the real distance, there's another step ahead of us, and we are going to get to that very soon. Now, if you observe this question very well, the one we have been solving earlier said angular distance. This one said find the distance. It means that's the real distance that you have to find. How will you go about that? Remember that in your spherical shape of the earth, where you have the north, the south as normal, you have the east and the what? Normally as it is now, we see this pictorially as a circle. Are you getting me? And the degree that make the circle, complete circle, is what? 360, isn't it? 3 what? 360 degrees. And any part of the circle to make 360 is called arc. And that arc means you are taking it out of the 360. Now, if you are to get the length of an arc, which now goes for the distance here, so the formula we'll be using normally, the formula will be what? Will be equal to what? Theta over what? 360 degrees times 2 pi r. Because 2 pi r is part of is the circumference, okay? And the part of circumference is this. But mind you, we can make a great circle or a small circle from here, depending on the question. So let's try to carve out the question and see maybe it is a small circle or a what? A great circle. Looking at it now, we have 30 degrees north. It is the 30 degree what? North. So it goes like this. This is 30 degree north. Okay. Against 50 degree what? West. This is the west. It swings towards the west, which is what? 50 what? So this line represents what? 50 degrees what? West. Where they met is the G. Do you get that? Now another one now, 30 degrees south. It comes towards the south. It's like this. 30 degree what? South. Okay. And 50 degree what? It's still the same thing. Okay. It means where they met here will now be what? H. Will now be what? H. By God's grace, this will make a great circle because it's coming towards here. Because what joins both of them is the longitude. So it's going to make a great circle. What? Great circle. So what we have to do first is what we have done earlier, which is the distance between here and here. Okay, we can do that very fast. So our theta, which is the angular distance, will be equal to what? From here to here is what? 30. So 30 plus what? Plus another 30. 30 plus another 30. That will give us what? 60 degree what? 60 degrees. Okay, that's our theta. So now calculate the distance GH. Distance what? GH. So it means distance GH, G what? H will be equal to what? Mind you, this is the radius of the earth and it's constant. Radius of the earth is constant. It's always 6,400 kilometers. It's a constant. So putting that into the formula here. So we have theta, which is 60. So 60 degrees divided by what? 360 multiplied by 2 multiplied by 22 over 7 multiplied by, now our R is 6,400, isn't it? Yeah. So multiplied by what? 6,400 kilometers. So let's do that, please. And let's see what we get. 16 million 896 what? Thousand. Divided by 360 times 7. 2,520. So the final answer, so our final answer will be 6,704.49 kilometers. So that's the distance. Instead of angular distance, that's the distance. So let's check another question. Now, this is another example. P and Q are two places on the same circle of latitude 79 degrees south. P is on longitude 68 degrees east, while Q is on longitude 22 degrees west. The distance between P and Q is, now what we have to do, as you know normally, is this. As it is now, they say P and Q. Now, what did they say first? They're on latitude of what? 79 degrees what? South. South comes down like this, isn't it? So it's around this place, like this. Are you getting it, please? So this is what? 79 degrees what? South. Now, P is on longitude 68 degrees east. East means it switched to the east here, okay? When it swings here like this, to the east. Do you see that? So this is what? 68 degrees what? East. And that's called what? P. So where they met is what? Is P. Is P. Okay? While Q is on longitude 22 degrees what? West. So it's going towards west now. So 22 degrees what? West. So where they met also here. So here is 22 degrees west. So where they met is our what? Is our Q. Is our what? Q. Mind you, this is the bend, okay? If you want to make a circle now, you must not start from here. Why? You look at where they started from. You first of all try to trace it. So it's going to be around here. So any circle you are going to make will be here. Please, do you understand what I'm saying, please? It will be in tandem with where they started, okay? You know it's curved. So by that, this is a small circle. So if you have to curve it out, it will be like this. You can see now, it will be like that. It's a small circle. It's a what? But mind you, we have to get the angular distance first. The angular distance is this. From here to here, is our what? Is our 68. Sorry, is our what? 68. So this place is the 68 degrees. And this place is the what? 22 degrees, isn't it? So to get our angular distance here, it will be 22 plus what? 68. So what will that give to us? That will give us what? 90 degrees. Do you get that? Now, mind you, this is a small circle. Why? Because it's not touching the what? The equator. And what is common to them is the latitude. Where latitude is common to them is a small circle. Are you getting what I'm saying? Because it can come down and go up. Okay? You can see it's a small circle. So what do we now do? There is a distance between the small circle and the equator. There is a distance between the what? And which I can just take the line and put it this way, or I put it here. So let me put it this way, where it started here. The angle here is what? Is 79. Is what? 79. So I call this one dagger. I call this what? Dagger. Instead of theta. This one is theta. I call this the dagger. Now, there is something I did not mention before, and I have to mention it now. If you want to calculate the distance in this one, is a small circle. So the distance QP, distance what? QP. The distance QP will be equal to theta over 360 degrees times 2 pi what? Instead of big R, it will now be small r. Because it's a small what? Small circle. Okay, not a great circle. But mind you, our small r also have a way we can relate it to big R. How can we do that? Our small r is equal to big R cos dagger. And this dagger is the distance of the latitude from the equator. Are you getting me? The distance of the latitude to the what? Equator is this dagger, which is 79 in this instance. So how do we do that? Instead of this formula, we have to rewrite it as what? Theta over 360 degrees, okay, multiplied by 2 pi what? Big R cos what? Dagger. You get that now? Yes. You substitute. So we now substitute all the values there to get our distance, and that's all. How do we do that now? So we have to say that's 90 degrees over what? 360 degrees times 2 times 22 over 7 times 6,400, which is the big R, cos 79 degrees. So let's calculate that and see what we get as the final answer. Let's calculate that. As the final answer is 1,918.99, okay? Kilometers. So if you want to approximate this to the nearest whole number, it will now be 1919 kilometers. So that's the distance. Now, this is another question that brings about a lot of things about longitude and latitude. All right. So we have P. The question says P and Q are 2 points on latitude 55 degree north, and their longitude are this and this. So let's draft it and let's see how it looks. Okay. So as usual, we have the north, we have the south, okay, and we have the east and the what? West. And we have the west, as usual. Yeah. Now, P and Q are 2 points on latitude 55 degrees north. 55 degrees north will be up here, okay, like this. So this is what? 55 degree what? North. And their longitude are 33 degree west. So it swings to the west like this. So this one is what? 33 degree what? West. So where they met will be our P. Will be our what? P. Because that's the first one. Now, and 23 degree east. 23 degree east comes towards this side. Okay? 20 what? 3 degree what? East. That will be our what? Q. Alright? To make this circle, I told you, we will now go for this. Look at where this one will meet. Okay, that's why we now make this circle. So this is a small circle. This is a what? Small circle, not a big circle. The first thing we have to do is to first of all get there. They say the parallel. Now they say we should calculate the distance between P and Q measured along what? The parallel of what? Latitude. What we have to do first is to get our what? Angular what? Distance. Okay, which is theta. How do we get our theta? Normally from here to here is what? 23. Here to here is what? 33. We have to add it together. Okay, it means 33 degrees plus what? 23 degrees, which is the continuation of the journey. This will give us what? 56 degrees. Okay, that's our angular distance. To get the normal distance, that is what we should get. That distance will now be equal to what? So distance PQ, distance what? Be equal to theta over what? Over 360 times 2 pi. Now it's small r. It will be what?
Small r.
And remember, recall that small r is equal to big R cos what? Dagger. And that dagger is what? Distance of this circle to here. You see now?
Yes, sir.
This place is the dagger, which is what? 55. Which is what?
55 degrees.
So it means we have to put it at 55 degrees. So let's substitute this one as big R, as small r. Instead of small r, we are going to write big R cos what? Dagger over there. Now our PQ distance, PQ is equal to what? What's our theta? 56 divided by 360, calculator, times what? 2 times 22 over 7 times 6,400 cos 55. Cos 55. So what will that give us? So the answer here will be 3,580.3 kilometers. Okay, so that is the distance between P and Q measured along the parallel of latitude. Now, the second one, along the great circle now. If you want to get along the great circle, there is something you have to do. Look at here, we have 55. Okay, you have to make this one also a line like this. Another what? 55. Okay, we want to know the distance along the great circle. Along the what? So if I have to carve this out, so something is like this, okay, and I make another thing like this. You see that? So to this place we have 55 degrees. We also have what? 55 degrees. Okay, and this one is making something like that and like this. So what are we going to do? We needed to find PQ along the great circle, and this is our great circle. This is the small circle. Okay, this is the what? The great circle. Along this side is the great circle, and we needed to find that distance. How do we now do it? We know 55 and 55, and everything on the straight line, angle on the straight line is what? 180. So it means 55 degrees plus PQ, okay, plus another 55 will give us what? 180. Are we there?
Yes, sir.
This 55 plus 55 is what? 110 plus what? PQ is equal to what? 180 degrees. Therefore, our PQ will be what? 180 degrees minus 110. So our PQ will be what?
70 degrees.
So now, the distance along the great circle is now what? 70 degrees. So now, after getting this degree, we are told to find the distance. So to find the distance, we have to use the formula of the great what? Circle, since it's along the great circle. So it means our distance PQ now along the great circle will now be equal to theta over what? 360. Theta over 360 times 2 pi what? Big R now. Times 2 pi what?
Big R.
So we have to put this value here. Okay. That will now be equal to what? 70 degrees over 360 degrees times 2 times 22 over 7. Okay. Times 6,400. So what should be our answer there?
Hmm? 7,822.
So the answer will be 7,822.2 kilometers. So that's the answer. Thank you and God bless.